Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapkod. Dear students, in the previous class we discussed what is thermal resistance and what is series thermal resistance. In detail we have discussed, and we have written the R total for the series combination. When the more materials are attached in series, if the heat is going to transfer in a composite planes or wall or slabs, there is a individual resistance offered by individual material. Then if they are in series, then we can write the equation for R total is equal to R1 plus R2 plus R3 plus Rn. Okay, that is what total resistance offered in a composite slab that we have seen. Okay, dear students, come today we will move towards next thermal resistance, next type of thermal resistance, that is a composite of you can see now two materials, they are arranged in parallel. Okay, so what is parallel resistance? First we will try to understand that. Okay, so parallel resistance, I will take two materials here now. Those two materials are arranged in parallel. Then I am going to supply heat at one end. The heat is going to transfer from high temperature region to low temperature region. But here the two metal plates we can take, or planes we can take, or slabs we can take, they are arranged in parallel to each other. Okay, so what is that parallel resistance? When the materials are arranged parallel, right, the heat you are transferring, then the heat is going to transfer from high temperature region to low temperature region, but the individual resistance is going to offer by individual materials, but those resistance are parallel to each other. How it is, that we can see here now, dear students. What is parallel resistance? When materials are arranged in parallel, the reciprocal of the total thermal resistance is the sum of the reciprocal of the individual resistance. That is nothing but what? 1 divided by R total is equal to 1 divided by R1 plus 1 divided by R2. This is the definition, dear students. Now with the help of an example, I will try to explain you what is parallel resistance. Okay, what is parallel thermal resistance? Okay, dear students, I will take two materials here now. I will take 1 minute. Okay, I will take two materials here now. Okay, so this is material A, I can call, or material 1 you can call. This is material B, and it is well insulated. You can see here now, well insulated at bottom and top. Now assume that heat is transferring in this direction, that to one dimension. The heat is transferring in only one dimension, dear students. That heat transfer is represented by Q. Then heat is going to transfer from this end, I will mark as high temperature region. This end I will mark here as a low temperature region. So that means what? Temperature at high temperature region I will mark here as a TA. Then temperature at low temperature region or cold region I will mark here as a TB. Hence heat is transferring from TA to TB. Okay, now dear students, you can see here now, when the heat is transferring from this end to this end, right? But here material A and material B are arranged in parallel. They are one another or parallel to each other. Okay, in that what happens, the heat will start to move from this end, right? Some amount of heat will try to move in. 1 minute. Heat will try to move in material A. Some amount of heat is going to transfer in material B. That means what? Heat is going to transfer, right? Material A, that is QA I can call. The heat is going to transfer, or else heat is transferring, right? That is Q, is common for all, common for both. Some amount of heat is going to transfer in material B. Then the heat transfer, the resistance offered by material A and material B are parallel to each other. Because material A is going to offer some resistance, that resistance you can mark as a R1 or RA. The material B is going to offer some resistance, that resistance we can call it here as a R1, R2 or RB. The resistance offered by material A, resistance offered by material B. Those resistance you can see here, dear students, they are parallel to each other. If I want to calculate the total resistance in this particular case, what I can do, I can calculate, that is nothing but what? Total resistance, that is the reciprocal of total resistance is equal to sum of reciprocal of the individual resistance. Here are the two resistance. Then how I can write, dear students? So reciprocal of, just a minute. Okay, so now reciprocal, that is nothing but 1 divided by R total is equal to what I can write now? R total is equal to sum of reciprocal of individual. Individual means what? R1 plus sum of reciprocal of individual, that is second one, that is R2. If there are n number of materials, here I have only taken for understanding, I have taken only 2. There may be n numbers. If there are n numbers, what I can do now? I can take R to the power of n, or else we can write it here plus dash dash. That means what? If there are more number of materials, then I can take Rn. Dear students, we know already generally what is R? Resistance offered by a material. When it is the conduction and transfer, then we know resistance formula. What is that? L divided by K into A. What is K now? Thermal conductivity. Yes, K represents thermal conductivity, A represents area of, then L represents length actually. Okay, where A1 represents what, dear students? We can see here now. A1 represents area of material 1, K1 represents thermal conductivity of material 1, then L represents length of both the materials. Both the materials are same. Okay, and both the ends are insulated at bottom and top, they are well insulated. Okay, then where A2 represents area of the material 2, then K2 represents thermal conductivity of material 2, dear students. With the help of this data, what I can do? I can calculate the total resistance which is offered by this composite material. That is nothing but what? 1 divided by R total is equal to 1 by R1 plus 1 by R2. Where 1 minute. Okay, now I will write it here. Okay, 1 by R total is equal to 1 by R1 plus 1 by R2, because I have taken only 2 materials here now. When 2 materials, then temperature at beginning point or starting is TA, the temperature at end is TB, dear students now. Okay, the resistance offered, this here what is actually what is flowing actually? Heat is going to flow, that heat is represented as a Q. Then the resistance offered by material A, I will call it here as a R1, then symbolically I will represent like this. So similarly at the bottom, material, heat is going to transfer in material 2 also, or material B also. The resistance offered in the material 2, I will represent it as a R2. Then I can represent symbolically like this. This is something but what? When the 2 metals are parallel to each other, the resistance offered in the parallel materials is nothing but what? Parallel thermal resistance, we can say, dear students. Okay, so now we know already R is equal to L by Ka, I told you, dear students. Okay, now what is I written, right? R1. What is R1 now? How to calculate R1? What is the value of R1? R1 is equal to what? What I can do now? That is, I can write it here now. L1 divided by K1 into E1. Okay, because general formula R is equal to L by Ka. But if you are applying that same formula for particular material, then it becomes what? R1 resistance offered in material 1, that is R1 is equal to L1 by K1 into E1. What is K1, A1? I already told. Similarly, if you want to calculate the resistance offered in material 2, that is nothing but what? L2 divided by K2 into A2. Okay, if I want to get the total resistance offered by these 2 materials, then I can calculate, that is 1 divided by R total is equal to what I can write? 1 divided by R1 plus 1 divided by R2, dear students. This is what? The R total for the parallel plates, when the 2 planes are parallel to each other, dear students. Okay, so the same thing, you can expand this R1 is nothing but what? L divided by K into A. Why it's so L? Because we have taken L is equal to L1 is equal to L2, that is LA or LB. So R1 is equal to, you can expand. Okay, R1 is L divided by Ka into A, then R2 is equal to L divided by KB into EB, dear students. Okay, fine. And one more thing, I have taken TA and TB. Some authors, they will take T1 and T2. That's also correct. But notation, you can take anything, but in the nomenclature, you have to give them complete description for that particular notation. Okay, now what I will do, these students. Okay, now if there are, now assume that I will take 2 materials, dear students. What I will do, I will take 2 materials. So I will call it as a material A and I will call it as a material B. Heat is going to transfer, that is heat I will represent here Q. The direction of heat flow I will show it here now. Then when heat we have supplied it, some amount of heat is going to transfer through this material A. Then that material A is going to offer some resistance, that is R1. When heat is going to transfer in this way, right, in this, so some resistance is going to offer by material 2, that resistance I can call it as a R2. Then resistance 1 offered by material 1 and resistance 2 offered by material 2, R1 and R2. Heat is moving in this direction, dear students. So okay, that I can thermally express that in terms of thermal circuit like this. Okay, so now this is what I can say now, dear students. You can take here, you are calling it as a TA and you are calling it as a TB. Hence what I can show that thermal resistance in thermal circuit, that is TA and TB, dear students. Now heat is transferring in material 1, I will represent here R1. Heat is resistance in some amount of heat is going to resist in material 2, that I will mark here as a R2. That means what, R1 is the resistance in the metal 1 and R2 is the resistance in the material 2 or metal 2, you can call, dear students. It is for what? When there are 2 materials I have taken for them analysis. If there are 3 materials, then how to write the thermal circuit? That is also important, right? Now how I can write the equation for here for total resistance. If I ask you to calculate the total resistance, then what you can do, 1 divided by R total is equal to what you can write now, 1 divided by R1 plus R2. This is for what? This particular case. If there are 3 materials, then how to write the equations? That's also important, right? Assume that there is a 3 materials. In 3 materials, the heat is going to transfer in 3 materials. Then what will happen? Some resistance is going to offered by individual materials. The resistance offered by material 1, I will take it here R1. The material resistance offered by material 2, I will mark here as a R2. Then resistance offered by material 3, I will mark here as a R3, dear students. Now this is what? Resistance. Okay, fine. Now if I want to calculate the total resistance, because heat is flowing in this direction, right, that is Q, that is TA and this is TB. Okay, if I want to calculate the total heat transfer, you can calculate the total heat transfer also. How it is? That is Q is equal to, we know, sorry, 1 minute. Okay, we know what is that resistance. Resistance can also be written as delta T divided by Q. So with the help of this resistance, I can calculate heat transfer also. With the help of this heat data and temperature, I can calculate resistance. Vice versa I can do. Okay, fine. Now if I want to calculate the total resistance, so what I can do here now, there are 3 materials. Yes, 1 divided by R total is equal to, or R equivalent is equal to 1 divided by individual, R1 reciprocal of individual, plus 1 divided by R2 plus 1 divided by R3, dear students, if there are 3 materials. Similarly, if there are 4 materials or 5 materials, material 1, resistance offered in material 1, I can take it here R1, material 2 R2, material 3 R3, material 4 R4, material 5 R5. That means what, there are 5 materials. In that 5 materials heat is going to transfer. Then how to write the equation? How to write the equation, dear students? 1 divided by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5, dear students. This is what total resistance offered in the 5 materials when they are parallel to each other. This is what, like that you can write thermal resistance equation for 6 materials also. The same procedure you need to follow, dear students. This is how to write the thermal resistance equation for the different materials which are arranged parallel to each other. The materials may be n numbers, 2 or 3 or whatever it may be, dear students. Okay, fine. Now okay, one minute. Okay, dear students, now I will take an example here. Now I will take a block. Okay, I will take an application, composite material. material A is there, material B is there, material C is there, material D is there. They are arranged like this now. Material, when we are seeing at front view, right, material A, B, C and D. When we are going to compose these two, right, we are going to get series. When we are going to consider these two, right, they are parallel. That means what? In this application, in this composite material, both series and parallel combination is there. Then for that, how to write the thermal resistance equation. That is also important, dear students. Now what I will do, dear students, I will draw the front view for this particular composite material. That is, what is front view? This is material A, right? Yes, material A. Then material B is there, material B and C. Then material D is there, D. I have written it here now. Dear students, material B and C are they parallel to each other. Then material, when we are going to combine these two, right, you are going to get material A is series with material B and C combination. Then material B C combination is series with what? Material D. Then how to write the heat transfer equation or thermal resistance equations here now? The heat is moving, right? I can take it here T1. Here I can take it as a T2 or up to you. So T1. So resistance offered in material 1 is what? R thermal A. Okay, that is okay. Then B and C are combined, right? Now how I can write now? It is a combined. R thermal resistance for B, R thermal resistance for C. Then this is what? Thermal resistance D. That I can write it here, R thermal D. So this is what? Now we can say here it is series and here it is series and it is a parallel. That means what? It is the application of what? Both series and parallel combination. Okay, then how to write the equation? That equation I can write it here now. R total is equal to, how I can write it now? R total is equal to, I can call it as a R thermal A plus, here I can write it here R equivalent because parallel is there. I will write it R equivalent plus R thermal D. I can write it, dear students, D. What is R thermal equivalent now? R thermal equivalent is equal to 1 by R thermal equivalent is equal to 1 by R thermal B plus 1 divided by R thermal D, R thermal C, dear students. Now when we are going to add this value in here, right, I am going to get the total resistance in this particular application. Dear students, hope you understood today's class. If you really understood, if you like my videos, please do support for me. With a lot of efforts, I am doing such videos for more and more videos. Your encouragement is highly required, dear students. Please subscribe my channel, share and do like and comment. Thank you. We'll continue next class.